Good morning, students. Today we are going to see module 4, that is disinfection. The outline of the topic goes like this: introduction, waterborne diseases, suitability of disinfectant, and methods of disinfection. So, when water comes out from filter unit, it will be having number of bacteria and microorganisms which are harmful in nature, that is, which are pathogenic in nature. So all these microorganisms should be killed or should be deactivated so that they don't spread any infection. So this process of killing the bacteria and microorganisms is known as disinfection. So the substance used in deactivating these microorganisms are called as disinfectant. So when microorganisms are not removed from water, there are chances of waterborne disease spreading more. So the removal of all these waterborne bacteria is known as disinfection. So there are some waterborne diseases which are listed over here. One is typhoid fever, which is caused by Salmonella typhi. The other one is paratyphoid fever, which is caused by Salmonella paratyphi. Next is cholera, which is caused by Vibrio cholerae. Next is bacillary dysentery, which is caused by Shigella bacillus. Then is poliomyelitis, which is caused by poliovirus. Amoebic dysentery, which is caused by entamoeba histolytic germ. So these are few bacteria, microorganisms and viruses which are spreading waterborne diseases. So there are chances of infection spreading more. So when we add disinfectant to water, the infection will not spread. So this process of avoiding the spreading of infection is known as disinfection. So the suitability of disinfectant plays a very important role. Disinfectant shall be effective in killing all the microorganisms. Means it should achieve at least 90% of killing of microorganisms. It should be cheap and readily available. Means it should not be costly and ready to use. It should be safe to handle and easy to apply. Means it should not cause any irritation to the person who is using it, and it should be easy to apply. It should not make water toxic in nature. Toxic in nature means poisonous in nature. Okay, it should not make water poisonous in nature. It should be non-toxic. It should have availability to present in residual state. Availability to persist in residual state means when we add this disinfectant to water, even after killing the microorganisms present in water, it should stay in water till it reaches the consumer. So it means it is in residual state. So there are different methods of disinfection. The first method is boiling method. So boiling is very easiest method of disinfection, but it cannot be used for large water supply schemes, or it cannot be used on large scale. But during spread of epidemics, we can advise the consumers to boil the water and use it. So boiling kills almost all the bacteria and virus present in water. The next is excessive lime treatment method. Excessive lime treatment method means it is application of lime to water. So application of lime to water may be in the form of powder, it may be in the form of slurry, or it may be in the form of limestone. Okay, but excessive use of this lime in water may lead to formation of carbonation in water. That is, carbon content may be more formed in water and it may make water corrosive. But it kills almost 100% of bacteria present in water. If carbonation is occurring, that can be removed by a process known as recarbonation. And the dose what we apply of this lime to water is varying from 10 to 20 ppm. 10 to 20 ppm means 10 to 20 mg per liter. We apply lime to water. The next is potassium permanganate treatment. So you might have seen in villages this method is more used. This potassium permanganate is nothing but KMnO4. So this KMnO4 is dissolved in a bucket of water, and the bucket of water is inserted to well, and they cause turbulence to water so that this KMnO4 is mixed properly with that well water, and they suggest that this water should not be used for 48 hours, that is 2 days. So when we add KMnO4 to water, the water becomes reddish in color. So the application of this KMnO4 kills 100% of bacteria and make the water free from infection, but it should not be used for 2 days. So this is potassium permanganate treatment. Then is treatment by iodine and bromine. So this iodine and bromine are present in the form of capsules. So these capsules are used by especially military troops. Military troops means when people who are there in military, when they move from one place to another place, there may be chances of they not getting proper treated water. Whatever available source is there, that water only they may consume. So to disinfect that water, what they do, in 1 liter of water they dissolve this one capsule. Okay, it is the capsule of iodine and bromine. They dissolve it in water and they disinfect that particular water. So that is treatment by iodine and bromine. Then next is ozonation. So ozonation, this process is nothing but it is called as treatment by ozone. Okay, so this ozone is not available here, so we have to generate this ozone. So to generate this ozone, what we do, we make use of oxygen which is present in the atmosphere. So when we have 3 molecules of O, it leads to formation of ozone. Okay, so to generate this ozone, what we do, we pass oxygen through high voltage electric current. So when we pass this oxygen to high voltage electric current, it gets converted to ozone. So you can see the equation written over there. So 3O2, when it is passed through high voltage electric current, it is getting converted to 2O3. But this ozone is unstable in nature. It easily breaks down. So it gets converted from O3 to O2 plus O. So that O2 is nothing but oxygen formed, and the O which is formed is called as nascent oxygen. So this nascent oxygen which is formed is used to kill the bacteria which are present in water. So this is how water is treated by ozone. Okay, we call it as ozonation. It is very costliest process. Why? Because when we pass oxygen through high electric current, it becomes costly. So there are many advantages and disadvantages of ozonation process. The first one is ozone being unstable. Nothing remains in water by the time it reaches in water to distribute the system, to distributary system. Then next, ozone removes the color, taste and odor from water in addition to removing bacteria from it. The ozonized water becomes tasty and pleasant, unlike the chlorinated water which becomes bitter to tongue. So these are few advantages. There are some disadvantages also. It is much costlier than chlorination. It needs electricity for its manufacture and hence can be used when electricity is available easily and cheaply. No residual can be maintained because it is highly unstable and hence it does not ensure safety against possible contamination. So if any future contamination is there, we can't avoid that contamination because this ozone will not be there to treat that contaminated water till it reaches the consumers. So these are few disadvantages. The next method is ultraviolet treatment method, that is treatment by ultraviolet rays. Okay, so this treatment by ultraviolet rays, you can see there is a picture given over here. Okay, so there is a bulb inside. Okay, so there is a bulb which is enclosed in quartz globe. Okay, so water is passed from the inlet on top. You can see this is quartz globe. Disinfection chamber is quartz globe. There is a bulb which is inserted in this quartz globe. Water is passed from top, from the inlet, so it is circulated around all these light. So inside this we have ultraviolet rays generated. So this ultraviolet rays disinfect the water, and from outlet the water comes out. So the ultraviolet rays offers an effective method of sterilizing of water. Since the light is effective in killing both the active bacteria as well as spores, though sun is the most powerful source of ultraviolet rays, it requires a large exposure area and long time. Hence, ultraviolet rays are generated by machines consisting of mercury vapor lamp enclosed in a quartz globe. So you can see that in the figure. Okay, so the destructive power of rays begins in the blue-green region of spectrum with a wavelength of 0.490 micron and increases in effectiveness to 0.149 micron. For disinfection to be effective, water should flow in a thin clear film close to the sterilizing ray. The depth of water should not exceed 10 centimeter. It should be colorless and its turbidity should not be more than 15 to 20 ppm. The method is costly and hence not commonly used except for private buildings, office buildings, institutes, and particularly swimming pools, etc. So you can see there are some advantages over here. Sterilizing with UV rays does not impart any addition like taste or odor to water as no chemicals are added. The method possesses ample scope for treating small quantities of water in hospitals and dispensaries for surgical uses or for drinking purpose for the place where cost is minor factor. The disadvantages: method is very costly, needs technical knowledge to work on this. Okay, and if electricity is not there, it fails. Okay, so next process of disinfection is silver treatment method. Silver treatment method, so you might have seen for small babies, they feed with silver spoon. Okay, so the reason for feeding the small babies is it is a good disinfectant. So anything which comes in contact with silver, so bacteria are killed when it is coming in contact with silver. So water can also be disinfected with silver, and this process is also known as electrocation method. Silver, when immersed in water, has been observed to exert an inhibiting action on bacterial life. In this approach, silver ions with or without activators such as palladium or gold are deposited on particles of granule activated carbon, a material which has exceptionally high surface area for deposit of silver. Bacterial laden water contacting the silver release minute quantity of silver from 25 to 40 parts per billion, that is ppb, which serves as a disinfectant. The contact time varies from 10 to 60 minutes. However, since silver is costly, this method may not be used only in small installations or for private individual houses. And the last method is chlorination. So you might have seen all these methods are costly, some are cheap. Okay, but depending on where it is available, for which source we have to apply, the method goes on changing. The best what we can use for large water supply scheme is chlorine. Why? Because it is available in abundant in nature, it is cheaply available, it can be easily handled, it can kill all the microorganisms, and it stays in its residual state till it reaches the consumers. So this chlorination will be seen in the next part. Okay, so stay home, stay safe. Thank you.